All right, guys, welcome to this page of the notes, and what we're going to do is begin to take a look at that first learning objective, which is going to be evaluating a polynomial for a value. Evaluating polynomial for a value. And again, what I've got here, same general definition for a polynomial that you guys saw on the first page of the notes. All I've done in this case, right, is just made it equal. I've named it as a function, right? F of x in this case, which is our standard name for giving a function. What you're going to be asked to do is simply this. You'll be asked, right, to evaluate, right, evaluated for numerical values, or this is really important, algebraic expressions. That makes it a little bit trickier, but we'll work our way through it, and you'll see what I mean here in a second. So numerical values or algebraic expressions. And again, here's the way it works. If you know an element in the domain, that means an x value, you're given a value of x, right? An element in the domain, then any polynomial function, you can find the corresponding value in the range. That's the y value, or what we'll call f of x. So here's just a real quick recap kind of what you're going to be doing. Let's say, for example, I give you this really simple function, x squared plus 2x minus 1. Remember the way the function works. What you're going to do is you're going to choose a domain value. You're going to choose an x value. Let's start with something really simple, like how about -1? Well, the way the function works is, remember, you can kind of think of it as a machine. What you're going to do is you're going to take that domain value that you just chose, or the domain value that was given to you. It's going to be one of those two things. Either I give it to you, or you get to pick your own. But somewhere you're going to get a domain value from. You take that domain value, or x value, and you drop it into our machine. Now, this machine represents the function that you've been given, x squared plus 2x minus 1. X squared plus 2x minus 1. So I'm going to drop my domain value into this machine, and what that means is everywhere I have an x, I'm going to plug in a -1. So -1 squared is a +1. 2 times a -1 would be a -2. And then I got a -1 on the end here. So what I wind up with is 1 minus 2 minus 1, which of course means that my machine is going to spit out a -2. So I wind up with a value of -2. Let's try another one. What if you plug in a domain value of 0? Well, I go and drop that 0 into my machine. I plug in a 0 for x, a 0 for x. Those guys all drop out. And what I get out of my function, my range value, is a -1. Let's try a couple more. If I plug in a +1, 1 squared is 1. 2 times 1 would be 2. 1 plus 2 is 3. And then I subtract 1. I get a +2. Plug in a 2. I plug a 2 into my function. 2 squared is 4. 2 times 2 is also 4, so 4 plus 4 would be 8. Minus 1 is going to be 7, right? All right, so you guys remember the way that these functions work. You choose a domain value, or it's given to you in the problem. You plug that into the function, and when we plug in the function, what we mean is you substitute that domain value everywhere you have a variable, right? It doesn't have to be x's. I can make these all y's. I can make them all z's, right? Wherever the variable is, you plug in the domain value, right? Evaluate the function once you've plugged in your domain value, and what you get out is the range value representing the value of the function given that domain value. Now, here's where they're going to get a little trickier. What if I gave you this? What if I asked you to plug in, let's say, a w? Well, guys, it works the exact same way. If the domain value you've been given is a w, you're going to drop a w into the machine. Everywhere you have an x, you're going to plug in a w, and what you get out is w squared plus 2w minus 1. Right? No big deal. Obviously, you're not going to get a numerical answer because w is a variable, but it works the exact same way. Don't let this throw you off. Just because they're giving you a domain value that's another variable doesn't mean that you can't do it. You just plug that w in everywhere. You had your original variable, and you get out your result. Let me give you another one. What if I gave you 2t? Oh, not red. All right, well, I want you to evaluate this function at the domain value of 2t. So everywhere I have my variable, I'm going to plug in a 2t. Well, here's what's going to happen. 2t squared means the 2 gets squared, that's 4, and the t gets squared. So that's going to be a 4t squared. And then I plug in a 2t here. 2 times 2 is also 4, and I'd have a t, so plus 4t. And then there's nowhere to plug in a 2t, so I'm just left with a minus 1 on the end. And once again, what I wind up with is not a numerical answer, but instead another polynomial where just what I've done is change the variable. I went from having variables that were x's to now my variables are t's. All right, really no big deal. So that's what we're going to be asking you to do. And when I come back to this page, when it says numerical values or algebraic expressions, guys, this is exactly what I'm talking about right here, right? I may give you a variable instead of a number. When you plug that in, you're going to get an algebraic expression back out. All right, so really no big deal. Here we go. Let's try a couple of these. So what I'm going to ask you to do first off is I want you to evaluate this polynomial given that domain value. You're going to plug in a 2 everywhere you have an x. So let's go ahead and do that. That means that f of 2 is equal to 4. This is going to be a 2 cubed minus 3 times a 2 squared plus 2 minus 1. Again, you can plug and chug, don't fat finger something on your calculator and all of that. Well, actually, you know what? I'll do it for you. 2 cubed is 8, and 8 times 4 is going to be 32. 2 squared is 4, and 4 times the negative 3, so that'd be a minus 12, and then I got a plus 2 and a minus 1, and so all of this comes out to 21. All right, I got a couple more for you here. This one, actually, I want you to do it twice. I give you the polynomial v of t, where t is your variable, and I've named the polynomial v, right? So the polynomial is named v. The variable in the polynomial is t, right? So I got a bunch of t's in here. Well, here's what I want you to do. I want you to find v of 2, and I want you to find v of 4. And these are two separate problems, so we'll do them separately. First, I'm going to find v of 2, which means everywhere I have a t, I'm going to plug in a 2. So negative 0.037, 2 cubed, 0.152, 2 squared, and 0.173 times 2. Again, I got decimals running around all over the place, so I actually already did these. Again, you can plug all that into your calculator, don't fat finger something, and you wind up with v of 2 being equal to 0.658. Again, shouldn't throw you off at all the fact that there are decimals in there. It's whatever. Decimals, fractions, you guys, it's Algebra 2. You can handle all that stuff. We still need to do v of 4, so let's go ahead and do that one. Again, I'm now going to, instead of plugging in a 2 everywhere I have a t, I'm going to plug in a 4. You've been given a domain value of 4. I want to know what's the range value. Well, we'll have to evaluate the polynomial to find the range value. We're going to evaluate that polynomial at the domain value of 4. All right, so there we go. I plugged in my domain value of 4 into all of my variables. And again, I got decimals, so plug this into your calculator, don't fat finger something, and you should come up with 0.756, right? Again, representing my range value. So again, here's the way it works. You are going to be given some sort of polynomial, right? You're going to be given a polynomial function. You will be asked to evaluate that polynomial for some domain value. You take the domain value, you plug it in everywhere you have a variable, right? And then plug and chug into your calculator, don't fat finger something, you're going to get out your range value. Guys, head on over to the next page of the notes. We'll try a few more of these, and I'll meet you there.